Yes, members?
Yes.
Can we continue?
Sure.
All right. So you have got the difference between outcome and sample space, right?
Yeah.
Outcome is what you get when you toss a die. That's what you get. But after trying out a given series of experiments, what you come out after that is what now you give you a sample space. And the sample space is denoted by letter what? Is denoted by letter S. I believe you're able to see what is on my screen. These are a set of possible outcomes of an experiment. A sample space is denoted by letter S. The number of outcomes is denoted by, so now members.
Yes.
What's the number of the sample space? How many do we expect from this? We expect 1, 2, 3, 4, 5, 6. Do we expect only what?
6
There are only 6 possible what? Outcomes. It will not, because we cannot get a 0 in a die when we toss a die. We cannot get a 7. So if they ask what's the probability of getting a 0 in a die, what will be your answer? Is 0, not so. It's not possible. It's not what? It's not possible. Okay? There's no way you can get for me a 7 when you toss a die. Unless if it is a die of a different kind. Another example we can also put there is like when you have when you throw a coin. When you're throwing a coin. Throwing a what? A coin. Like mine is here. Like you can see it from there. This is 200 shilling note. So I will take this one to be the head. I wish I have 500 shilling. Members, I don't have 500 shilling here. Let me check. Hey, I have one here. Is there? Is there? So when you toss this, like now when you toss this like this is the head, this is the what? The tail. So when you toss this, there's, members, you can see these are the only 2. What is the sample space there, members? What is the sample space? There's only 2, not so. You can either get a tail or a what? A head. So the possible outcomes. So the possible outcomes is either the head or the what? The tail.
The tail.
So which means our sample space will be what? Head and what? Head and what?
Tail.
Head and tail. So what's the number of the sample space? What's the number of the sample space?
2.
Is 2. 2 what? 2 outcomes. Are we together, members?
Yes.
Yes. But if I have 2 coins, now here I have 2 coins. What about if we have 2 coins, members? You are tossing 2 coins at the same time. Tossing 2 coins. Tossing 2 what? Coins. What will be our sample space? What's the possible outcomes? What's the possible outcomes?
4.
Head and head.
So our sample space will be, the first coin can show the head, not so?
Yes.
Not so. We can have head, tail.
Okay.
Not so? We can have tail, tail, head. We can have tail, tail. Not so?
Yes.
So what's the number of our sample space?
4.
Is 4 what? Outcomes. Is 4 outcomes. So it means when you are tossing a coin, there's no way you can get less than 2, I mean less than 4 or more than 5 outcomes, because here you are exact, because those are the experiments you have been trying out. So you can get head, 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 tail, tail, head, tail, tail. Okay? Let's see, how do we generate a sample space? How to generate a sample space? Take, for example, a coin, 2 coins. 2 what? 2 what? 2 coins.
Coins.
You draw a simple table like this. Are you seeing, members? Are you seeing that?
Yes.
You just draw a simple one like that. This is the first coin, then this is the second coin. In each coin, I expect a head and a what? A tail. Even this one, I expect a head and a what? A tail. Okay? This one is when 2 coins are what? Are tossed together. Are tossed what? Together.
Yeah.
So which means I will get head, head. I think that head, head. What do you get? Head, tail. Now when I come to
Tail.
this is what? Tail, head,
Tail, tail.
then tail, tail. Now what we have got here, this is our sample space. This is our sample what? Or probability sample. Okay?
Yes.
Members, are we together?
Yes.
Yes.
What about 2 dials? What about 2 dials? What about 2 dials? Let's see how we generate that sample space. We said if it's only 1, what do we get? If it's only 1, what do we get? There's only 6 possible outcomes, not sir?
Yes.
Yes.
Now let's see, what about if there are 2? How many should we get? So this is dial 1, this is 1, then this is the what? The second one. You can put it the way you want. You can put the second one here, the first one there. But in each of them, we expect 1, 2, 3, 4, 5, and what? And 6. Even this one, I expect 1, 2, 3, 4, 5, and what? And 6. Okay?
Yes.
So which means if I toss all of them together, there's a possibility I will get 1, 1. Not sir? I get 1,
Yes.
2. I get 1, 3. I get 1, 4. I get 1, 5.
5.
I get 1 what? 1, 6.
6.
Now I come to 2. I get 2, 1, 2, 2, 2, 3. I'm using the first one. So which means 2, 4,
4.
2, 5. I can get 2, 6. Not so members.
Yes.
You can get 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Let me know people are writing this thing down.
Yes.
Yeah, I get 4, 1, 4, 2, 4, 3, 4, 4. 4, 5. Then 4, 6. Then here I expect 5 what? 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, then 5, 6. Then the last one, 6, 6. I mean 6, 1, sorry, 6, 1, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, then what? 6, 6.
6, 6.
So what is our sample space? The sample space are these ones. Are you seeing that? So when you count them, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. There are how many?
36.
So which means the number of sample space. The number of sample space here is what? 30 what?
36.
36 what? Possible outcomes. Members, have you seen that?
Yes.
But if it is only 1, we expect how many? What will be our possible outcomes?
6.
For coin, if it's only 1, we expect what is the possible outcome?
2.
2. Yes, like that. Are we together, members?
Yes.
Let's look at the third term. An event. An event. What do we mean? What we talk of an event? What do we mean?
Sample space.
Now, an event is a subset of a sample space consisting of sample point of interest. Now here is what you are interested in. Here is it, we talk of sample. We talk of what? Sample point of what? Of what, members? Of what?
Interest.
Sample point of interest. Sample point of interest. Sample point of interest. And it is denoted, it is denoted, it is denoted, it is denoted, it is denoted by a symbol, is denoted by a symbol, capital what? Capital E. Are we together? Members, are we together? So as an event is now what you are interested in. Because when we are doing experiment, when you're doing experiment, you may not be sure of, but now you set a target. You can't just do it for the sake of doing, you set your target. Okay? You said, I want, like if you are playing a Ludo, if you are playing a Ludo, what is your interest first? What would be your first interest?
6.
The first interest is to get a what? A 6. Not so?
Yes.
Yes. The first interest is to get a 6. So which means 6 become our interest. 6 become our what? Interest. Now, how do you get probability now? That is enough. How do you get probability? We said probability of any event. Probability of any event. Probability of any event is given by. So probability of any event, that's how we write it. Probability of any event is given by the number of event divided by number of sample. The number of sample what?
Yes.
Sample space. The number of event divided by the number of sample space. Are we together, members? Mm-hmm. Now, examples. Let's look at some examples now. Examples. Now, assuming 2 dials, I mean 2 coins. 2 what?
Coins.
2 coins are thrown together. So this is the first one. This is the second one. In each of them, we expect a head and a tail. Head and what? A tail. So now, which means here, what do we expect here? Here is a tail, head and what? Head. Here we expect head and what? A tail. Here, what do we expect? We expect a tail, head. Here, what do we expect? A tail and? A tail. Now the question will be said, what is the probability? What is the probability of getting, what's the probability of getting, Roman 1, 2 heads? What's the probability of getting 2 what? 2 heads. So what's the chance of getting? We know that we know the probability. Just start by writing the formula. Probability of any event is given by the number of event over our sample what? Our sample space. So here, what is our event, members? What is our event? Our event is it? We must get how many heads?
2 heads.
2 heads. That's the point of interest. That's the sample point of interest. That's our event. So what is our sample space? From here, when you look at this, what is our sample space? Our sample space is what? Is 4. So it means now the probability, now you come and say probability of getting 2 heads. That's how you write it now. Probability of getting 2 heads will be equals to, what is the probability, members? How many times are you seeing 2 heads here? Is it How many times? It's only once. No, sir?
Yes.
So which means it's going to be our event, which is 1 over what? The sample space, which is what? Which is 4. So which means the answer is 1 out of what? 1 out of 4. Another question may be of getting 2 tails. Of getting 2 tails. So probability of 2 tails will be? Members, who can give us what's the probability of getting 2 tails?
1.
Is 1 out of what? 1 over what?
4.
1 out of 4. But if they asked you, what is the probability of getting a head and a tail? A head and a tail. What's the probability of getting a head and a tail? In that order, here you have to be very careful of the order. Head and a tail. What's the probability of getting a head and a tail? So where is saying, I think head and a what? Head and a tail is only what? Is 1, not so? The number of event is 1. So which means they become 1 out of what?
4.
1 out of 4. But if they asked you, what's the probability of getting a tail and a head? In that order. So what is the answer?
1 over 4.
Is
1 over 4.
Is 1 over 4. I think that, members?
Yes. Yes.
Yes. Now, there is something very interesting here, members. There's something very interesting. If I had a probability of getting 2 heads, if I had a probability of getting a head and a tail, if I had a probability of getting a tail and a head, and if I had a probability of getting a tail and a tail, the answer must be 1. Can we prove it?
Yes.
Probability of a tail, plus probability of a tail, head, plus probability of head, tail, plus probability of tail, tail. For this one, we got what? We got a quarter, not so? Plus a quarter, plus a quarter, plus a quarter. What do you get? Is it not 1, members? Is it not 1? A quarter plus a quarter give us a half. A half plus a quarter give us 3/4. 3/4 plus a half give us 1. Not so?
Yes.
Yes. As simple as that. Now, what does that one mean? What does that one mean? It means that probability of any event, probability of any what? Event. When you add, the total probability must be 1. The total probability must be what?
1.
Must be 1. That is it. Then example number 2. Example number 2. Let's look at for the case of the dials. For the case of the what? The dials. 1, 2, 3, 4, 5, 6. 1, 2, 4, 5, 6. So this is our dial 1. This is dial 1. This is dial 2. So here we shall have what? 1, 1. This one you have already generated them, not so? 1, 1, 1, 2, 1, 3. This is 1, 4. This is 1, 5. That is 1, 1, 6. Up to the last one. That one we have already generated it, not so?
Yes.
Yes. Now, the question will come. The question will come. What is the probability? You complete for me this table, please. We already have it. What is the probability? What is the probability? What is the probability of getting odds? The first one may be what? Odds. Okay? Probability of getting what? Odds.
Odds.
Which means in that particular set here, in here,
Numbers.
in this one here, okay? Which means we must get only what? In that sample, we must get only odds. Now you start looking at, is one an odd number? One is odd number, not so? So this is odd. I think that. Members, I think that?
Yes.
Uh-huh.
Yes.
What about this one? 1 and 3, they are odds. 1 and 4 is not odd because 4 is even. 4 is what? 4 is even. We go to 5. We go to 5. 2 and 1, 2 and 2, 2 and 3, no. 2 and 2, no. 2 and 5, no. 2 and 6, no. Because all the set must be odds. All the set must be what? Odds. We come to this. We come to 3 and 3. 3 and 3, they are odd. What about 3 and 4? Remember, is 3 and 4 odd? Is it a set of odd?
No.
What about 3 and 5?
Yeah.
What about 4 and 1?
No.
So which means 4 is out. This line of 4 is out. We come to 5. 5 and 1.
Yes.
5 and 3,
5,
yes.
2,
Then 5 and what?
5.
5, 5.
5.
Have you seen that? How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are how many?
9.
There are 9. So now, which means when you come here, probability of getting odds, probability of odds is going to be equals to our sample, our event is what? We got what? We got what? 9. What is the sample space? What is the sample space, members? Is that what? Our sample space we got was what? Was that what?
36.
Reduce it if there are common factors. Are there common factors here, members?
Yes.
By 9, 1, by 9 what? 4. So which means is what? Is what?
A quarter.
B. What's the probability of getting evens? Check for me and get for me the probability of getting even numbers. Only a set of even numbers only. Set of even numbers only. The first one is move line by line so that you don't skip any. Is this one the one? Even, they want only even numbers. Even numbers, these are numbers which can be divided by what? By 2. So which means in that set, all of them must be divisible by 2. They must all be even numbers. They must all be even numbers. Do you have it in the first line there? Are you seeing any there?
No.
What about the second one? Is this one the one?
No.
What about this one?
Yes.
That one is yes. What about this?
2, 4.
2,
No.
4.
2, 4.
Yes. 2,
Then
2,
6.
6.
2, 6.
Then we go to 4, 2.
4.
4, 2.
4,
4,
2.
2.
4, 4.
4, 4.
4, 4. Then 4.
And 4, 6.
4, 6.
4, 6.
What about 6?
6,
6, 2.
6, 2.
6, 2.
6, 4.
4.
6, 4.
6, 6.
Count. How many are there? How many are there?
9.
There are also how many?
9.
There are 9.
9.
Good.
9.
So what is the probability of getting? So the probability of getting what? Evens
Even.
is going to be 9 out of 30. 9 out of
Out of
36.
30.
Out of
Which-
30.
Which is the same as
Is
1,
equals to a quarter.
which is still a quarter. Okay?
Yes. Yes.
Yes.
Then C, what is the probability of getting a odd, and even, odd and even, which means either one of them is odd, so just let me say, what is the probability of getting either a odd or even? Let's come back to our table here. So which means one of the numbers is either odd or what? Even. So what is the probability? What is that?
Hold on.
What would be the probability, members? You can see from here, all of them, not so. This one is odd. This one is
Yes.
odd and even. This one is this one one? Because we want either is the odd or even. One of them in that bracket, one of them must be odd and then another one must be even. So which one is that? We have this one, right?
Yes.
1 and 2. Which one again? 1 and what? 1 and 4.
1 and 4.
Then 1 and
1 and 6.
1 and 6. 2 and 1. I think that.
Yes.
Yes.
Is 2 and 2 correct? 2 and 2 all are even. That one is not correct.
That's correct.
2 and 3.
2 and 3.
2 and 5. Okay?
Yes.
3 and 1. Is 3 and 1 correct?
Yes.
Are you for real?
Yeah. No.
Odd or even? Odd or even? Is not. Not so? 3 and what?
Yeah.
3 and 2. 3 and 2. 3 and 6. I think 3 and 6.
Yes.
Yes.
What about 4 and
4
and 1?
What of 3, 4?
Hey, 3, 4 is here. Good. Thank you for seeing it. 3 and 4.
4, 3.
4, 3. 4, 5. Not so?
Yes.
Yeah.
5, 2. 5, 4.
5, 4.
5, 6. Not so?
Yes. Yes.
6,
6, 5.
6, 1. 6, 1.
6, 1.
6, 1.
3.
6, 3.
6, 3.
6.
6, 5.
6, 5. If you count them, how many are there? If you count all of them, how many are there? Count them. How many are there? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
18.
There are how many members?
18.
Let me hope I did not skip any. Let me hope I have not skipped any. So there are what? Yours there are
18.
There are 18, eh? So which means probability of either odd or what? Or what? Or even is going to be 18 over what? 30?
18 over
Over
36.
What do you get? If you simplify that, what do you get?
2 half.
It's a half, no, sir?
Yeah.
It's a half. Are we together, members?
Yes.
Yes.
Very good.
Yes.
Yes.
Members, note this one
Yes.
down. Note this one down. Note. Probability of any event, lies between 0 and what? 0 and what? Probability of any event lies between what, members?
Lies between 0 and 1.
That is 0 less than or equals to probability of any event less than or equals to 1. Who can make sense of that statement? Probability of any event lies between 0 and 1, which means there is no negative what, members? There is no negative?
Negative probability.
And there's no probability that goes beyond
1.
1. There's no probability that goes beyond 1. And there's no probability that is less than 0.
0.
0.
So that one is that is the marking point. Whenever you are doing any calculation on probability and you got your answer is negative, just know you are wrong. Don't even waste your time bringing it for marking. Okay?
Yes.
Just know you are what? You are wrong already. if you're working any probability and you get any probability 1 point something, that one you're already wrong, members. Don't even waste time. You're already wrong. Just know you have already made mistakes. Just go back and correct the mistake. Okay?
Yes.
Sure.
Yes.
Yes.
All right. Now let's look at these examples, yeah? Let's look at these examples, yeah? They're saying 3 coins are tossed. This time we have how many coins? How many coins, members?
3.
3. Now, if it was only 1 coin, members, let me, I want to give you a perspective. If it was only 1 coin, how many sample space did we have? We had 2 what? There was 2 what?
Outcomes.
Now, if there are 2 coins, we got what?
4 outcomes.
We got 4 outcomes. Now there are 3. What would be our possible outcomes?
6.
Are you sure it's 6?
8.
Huh? There will be what? There will be what?
8.
There will be 8 possible outcomes. Okay?
Yeah.
So which means in that particular question, our sample space, the name of the sample space is already what?
8.
8 what? 8 outcomes. So which means our sample space is 8. Now they're saying state the probability that when used to find a probability of how many? 3 what? 3 heads. What's the probability of getting 3 heads? Members, what's the probability of getting 3 heads?
4.
1/8.
Is 1/8. Good. 1/what? 1/8. What does it mean? Because we are tossing them at the same time. What's the probability that in all the 3 coins is only the heads that will appear? It's only ones. Okay? Are you together, members?
Yeah.
B. What about 2 heads? 2 heads?
1/4.
Huh?
1/4.
1/what?
4.
1/4.
2.
Are you for real? Members, maybe let's generate our sample space first. I think what we did here, the sample space. So which means you can get head, tail, head, tail, head, tail, head, tail, head, tail, head, tail, head, or tail. Members, have you seen that?
Yeah.
Yes.
Yes. So when you look at that, how many heads is appearing there? How many heads do we have there? How many? There are 3, not so? Because they're saying 2 heads. 2 heads. Let me write here so that you can see. Our sample space was head, not so? Head, tail, okay? Or you can have head, tail, head. Is there any other option there?
Tail.
You can have head, tail, okay?
Tail, head.
You can have tail, head. You can have tail, head, tail. You can have
Tail, head.
tail, head. Or you can have tail.
Tail.
Not so?
Yeah.
How many are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8. I think that?
Yeah.
These are our possible outcomes. This is our possible outcomes. That's why we said our sample space is 8. Our sample space is 8. Now, they want us to find when you look at here, what is the probability of getting 3 heads? This is only ones, not so? This is only 1 here, not so?
Yes.
Now they want us to find what's the probability of getting 2 heads. Probability of 2 heads. You can see here we have two heads, not so? In this one here, I think this one. So this is one. That's we
Yes.
have two heads. Here also two what? Two heads.
2 heads.
Where else?
There.
Here. So how many? How many? Are they not 3?
3,
So which means it becomes 3 over what?
8.
3 over 8. It cannot be divided. You leave it like that. Okay?
Yeah.
See, what is the probability of getting a tail? Probability of getting a tail. One tail. I mean, of one getting a tail. Who can give us that? What is the probability of getting a tail?
3 out of 8.
Eh? A tail,
out
only
of
one,
8.
only one tail. A tail, one tail. What is the probability of getting one tail?
2 out of 8.
It's 1 out of.
Is it only one members?
One
Yeah, I'm seeing here one. I think that
2 out of.
It's
I'm seeing a
2.
tail here.
2.
I'm also seeing a tail here. I think that I'm also seeing a tail. I'm also seeing a tail here.
3.
They are what? They are 3. So it's 3 over what? 3 over 8.
of 8. At
So-
most 1 head.
What's the probability of getting? What's the
At
probability?
most 1 head.
What's the probability of getting? Let me set 1 here. The rest are the same. They are the same. What's the probability of getting 3 tails? Members, what's the probability of getting 3 tails?
1 out of 8.
1 out of 8. Good. Good. Members, our time is running out. Do you have any other lesson coming up?
No?
I think after this, let's join back. Let's join back because in the first 40 minutes I was explaining other things. Can we join back and we continue when our time get done?
Yes.
All right. All right. Then when you look at the question that they're asking, what's the probability of getting at most one what?
1 head.
Now that one, English matters. English also matters here, members. Probability
English
of
in
at most
most
one what? One what?
1 head.
Epido? Otim?
Yes.
Otim, if I said, give me at most 1 pen, how many pens are you going to give me?
1.
Oro?
Sorry?
Oro?
None.
Or none. Good. At most, which mean maximum must be what? Maximum must be 1. Okay? Or you cannot give me. You can give me 1 or you cannot give me. Okay?
Yes.
Yeah.
But if I said give me at least 2, give me at least 1 pen, how many pens can you give me, members?
1.
1 or more.
One or what? 1 or more. Okay? Now
Yes.
here they said at most 1 head, which means you can either have a head or you don't have a what?
A head.
1 head or what? Or what? Or none. So from here, which one is that? Where we have only 1 head, look for me 1. Where is it? Well, we have only 1 head.
HTT.
This one, we have this one there, right?
TTH.
Yeah. TH2.
This one here.
THT. THT. THT.
This one here. Good.
TTT.
TTT. Good. So how many are there?
4.
There are 4. So which means it becomes 4 over what? Over 8.
Or 8.
Which is
Over
the same,
8.
which is the same as